Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 6D assignment. Okay, number one, for each of the following, sketch y equals x squared and the function on the same set of axes. In each case, comment on the direction in which the graph opens and the shape of the graph. So, y equals x squared. If we got y equals x squared, if we do our little t-chart, we got x, -2, -1, 0, 1, and 2. Right? And usually over here, instead of putting y, I'll put the x squared just so I know what I'm doing with it. -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So if you'll remember, we got 0, 0, 1, 1, 2, 4, and then we also got -1, 1, and -2, 4. Okay, and then so this is our regular graph, our regular y equals x squared graph. Okay, and then now we're going to do the same thing, but now with 5x squared. So, really what I'd like to do here is just extend this over, and then let's do 5x squared. So basically we're just taking the x squared and we're multiplying it by 5. So this is going to be 20. 5 times 1 is 5, 0, 5, and 20. So graphing that on the same graph, we'll do this in red here. So we're still at 0, 0, and then at 1 is now up at 5. -1 is up at 5. +2 is up at 20, which is way up here, so I won't even worry about that one. And so now we'll just sketch this graph here. It looks like that and like that. So this is A. Okay. For B, again, let's just continue on here. Let's make ourselves another graph here, and now this is -2/3 x squared. Okay, so now we're just taking our x squared and multiplying it by -2/3. Ooh, so that's not a nice one. That's -8/3. Excuse me, 1 times -2/3 is -2/3. This is still 0. This is, let's see. Yeah, so because we're multiplying by negative. So this is -2/3, and this is -8/3. Okay, so we'll still have our regular y equals x squared graph here, which is this one. Okay, and then our new graph is going to be this -2/3 x squared. So 0 is still at 0. Let's say 1 is now at -2/3, so 1 is at 2/3. -1 is at -2/3. 2 is at -8/3, so that's what, like 2 and 2/3. So -2 and 2/3 down about there, and this one's down about there. So, oops, goes out like that. This one goes out like that. So since this here, this 2/3 is less than 1, it means it's a little bit wider than the normal one, and also since it's negative, it opens down. Okay? All right, let's take a look at number 2. State the coordinates of the vertex of each function and explain whether the vertex is a minimum or maximum or minimum turning point. Vertex. Okay, now if you think about it, we got our regular vertex of y equals x squared is 0, 0. The only thing we're doing with the 0 is multiplying it by 3. So guess what? It's still 0, 0. Okay? And then since it is positive, it opens up like so. And it says, is the vertex a maximum or a minimum? So is this a minimum point or a maximum? That's the lowest it ever gets. So this would be a minimum turning point, they call it. Okay, turning point from where, like as we're moving, say, left to right, on this case, it stops going down and it starts going back up. That's the turning point. Okay. For C, vertex, on this one here, again, we're taking 0 and we're multiplying it by -1/3, which is still 0. So it's still 0, 0. And then this one, since it's negative, it is opening down. So then that means that this will have right here a maximum turning point. Okay? All right, that's all there is for this assignment. So if you have any other questions on any of these that I didn't do, please feel free to ask. Thanks.